So welcome all. Today we are trying to say something about transaction recovery. We all understand till now that transactions are there in distributed environment. They do execute sometimes there are certain cases where deadlocks may occur. We have seen in certain cases some transactions may abort. And also in certain cases, since it is distributed environment, then certain servers may fail. Failing of server means crashing, right? A server may crash. Now the thing is, the transactions which are going on, running on the server. Now what should be done with these transactions which were in between? So we need to recover these things, right? So there should be a proper fault tolerance mechanism, proper recovery mechanism where these can be restored as needed. Now the thing is, we understand the atomicity property of a transaction. It requires that all the effects of the committed transaction should be reflected in the objects they have accessed, and as well as those transactions which have aborted, their incomplete effects should not be reflected in the objects. So there are two things. One thing is durability and failure atomicity. Now durability and failure atomicity, you can understand these both the things. Like you had heard about durability in your maybe database classes or database classes only. So in durability, what happens? Whatever we have submitted, right, whatever we have committed, once it has been saved to the permanent storage, it will be available indefinitely thereafter. It will not be removed from there, right? It will not become unavailable someday. It will always remain available, right? So you see in two-phase commit protocol, we have seen that what happens, there is always a acknowledgement from the side of server that yes, we have committed, right? So have committed message, it shows that yes, it has been permanently written in the permanent storage. Failure atomicity was something which means if at all there is the transaction, so the effect of this transaction should be atomic, which means if at all it commits, then it's okay, all of the operations should be reflected in the permanent storage. And if it fails, failure atomicity means it should not affect any of the operation. Okay, so these are certain things, so durability and failure atomicity. But in a way you will understand that these both the things are somehow pointing towards the same thing, that in case of failure, it should be able to recover, right? Means if at all we are saying it is durable, it means if system crashes, even then whatever written permanently, it should not be removed, or there should not be any problem to that thing which has been stored. And in case of this thing, failure atomicity, what is say, if it fails some transaction, going on transaction, then in that case it should be none of the transactions should be affected in permanent storage, as well as those part of transaction which have been performed till now should be restored, right? So for these kind of things, we actually have something we call here recovery file. Okay, recovery file. What we do actually, whatever information related to new advancement, whatever I say, new updates have been done to the objects in the server, this is written in the recovery file. Okay, so for this we will need a recovery manager. There is a recovery manager, means definitely a software program, but a recovery manager in your software, this server, which will help you in few things. What are these things? This recovery manager will save the objects in permanent storage for committed transactions, restore the server's objects after crash, reorganize the recovery file to improve the performance of recovery, as well as reclaim storage space in the recovery file if at all needed. So these are certain things that will be done by recovery manager. So we also understand that we use replication kind of things in our system, right, distributed system. So for what? For this resilience, right, resilience, where something is, data is, if certain crash happened, even then the data is protected, right, that kind of thing. Okay, so there is one more thing that we have to know is intentions list. Okay, yeah, here it is. So what happens with intentions list? Actually, every server will manage intentions list for the transactions. So what actually happens here is every transaction will have this intention list. Oh, let me start. What I said is for every transaction we are maintaining this intentions list. I will tell you what it has, and every server manages intention lists for all the transactions, okay, in which it is involved. So here what is saying that in intentions list, okay, we have the values and the objects which are being referenced with the transaction. So for a particular transaction, suppose transaction T, you will have a list of references and the values of the objects that are altered by the transaction. Okay, suppose what it can do, it can access object 1, and what will be the value? Means definitely suppose value, it will not have actually value. Value means it is the object, it will also have the reference. Okay, list of the objects. So actually it will have this thing as well as a pointer to the place where this particular information is stored. So values of all objects is saying this thing only. So you will have another object, object 2, and pointer to its position where it has new value. Okay, so similarly other objects and their location. You will see, we will see in logging, when we will see how log is prepared, there we will see how actually these intention lists are being saved and used. So other thing one have to understand that this recovery file, definitely it will store the information of the transaction with its this thing, intentions list. It may store some more information. What this information can be? This can be the information related to the object and the value of an object, which means suppose it is object 1 and its value is 300. This is an information, this can be stored transaction status, it can store transaction status. Suppose the entry can be T and the status is either prepared, committed or aborted. So T committed. Okay. So this kind of entry can be done. Now the other kind of entry is intention list. You can write an intention list in the entry. Your entry can be like your transaction number as well as the list of entries, list of this thing, intention list. Okay. So these type of entries can be there. So now we are going towards two mechanisms. We will see two approaches actually which are used for recovery files. Two ways of having these recovery files. One is logging, another is shadow versions. So recovery files, we are understanding that it has to manage the order in which this were executed, the transactions were executed, and what is the current scenario. It will be saved there, and in case of a crash and we have to restore the values, this recovery file can be used, right? So first thing that we are going to see is logging. So in this logging, what happens? Actually the recovery file represents a log. It will be a log file kind of thing, which will contain the history of all the transactions performed. Okay. The history consists of values of the objects, all the three entries that we have seen. It can be either the object value pair, it can be status of the transaction, it can be transaction intentions list. These all the things can be there. The order of the entries in the log reflects the order in which the transactions have prepared, committed or aborted. Okay. So suppose let us see one example here for banking service. So initially here you can say these are pointers, I can say P0, P1, P2 and so on. So you can take them as the memory locations kind of thing. So here you see before this double line, this is P0. In this P0 we have objects and their value. Object A and the value is 100, B 200, C 300. No problem. Now what is happening? At P1 what happens? Object A is modified and the new value is 80. At P2 object B is modified and the new value is 220. So this operation was done and simultaneously the values were kept in the this log file, I should say the recovery file. Then it prepared for the commit. So there was an entry that it has prepared for commit with the this list. What is the list saying? You can see A P1 means A is the object whose new value is at P1. B, the new value is at P2. Okay, and the old values can be found from P0. So at this point, if you want to checkpoint, if this is the checkpoint, here if you want to update this particular transaction is not done, in that case you can refer to P0. Okay. Now this is P4, where we are just mentioning the status. The status is for the transaction T, the status is committed. Here it is saying that we have to see this thing P3, right, where what has to be committed, right. It has been prepared with this list of intentions, and according to this list what happens, it is committed. So there is an entry of commitment. After that you can see another transaction was U, which was working on C and B. So suppose the new value of C is this and for B it is this. So it says that it has been prepared. So at this moment there is something, this log file, actually here you can see that there are two transactions, T for which we are saying that it has been committed, another transaction U for which we have updated that it has been prepared. In this way a log file can be maintained, and this can be used as a recovery file. Okay. So what happens in case of recovery, in case of crash, how will this will be recovered? There will be two ways. First way is from a start, and the second way will be backward. I should write it forward, and this can be backward. So in forward what will happen, it will start from beginning, and in the direction from a start to end, whatever the operations have been performed, it will be performed again. Okay. So in the backward operation what will happen, it will start from the backward, and here it will understand, okay, this is a transaction, it is U, it has been prepared, so okay, it has just prepared, so keep these values here, and the values has not been reflected in the permanent storage, let it be here. This has been committed, okay, this has been committed, that means the values has to be stored in the permanent storage. Go to the P3 and see the values what has to be updated. It says there are two entries for A and B which has to be updated, and the values, other values of P0 can be found directly here. So it directly comes to P0 and restore other values. Okay, so this is how it will work in recovery. So one more thing that here you should understand, that sometimes suppose this is going to be a large log file. In that case you will need to reorganize, right? So if you will reorganize, means if the system, this recovery manager will reorganize, what it will do, it will take help of this checkpointing. So it will whenever a transaction is committed, for there it will perform there it will keep a checkpoint. So suppose keeping the checkpoint, it will help you to get the information stored at this process, I mean at this point. Okay, actually it will be more helpful in this backward recovery, you know. So this is kind of thing where checkpointing will be used. I was talking about reorganizing. What happens is in this case where we have this information, and when it will grow larger, in that case certain objects which have been already sent to the this thing, permanent storage and those kind of things. Now what we can do, we can create a new log, let me call it new recovery file, right? So now the next entries will be done in new recovery file. So till now whatever the committed entries are there, maybe here it will be committed, so whatever committed entries are there, they will be kept here. These small entries will not be there, committed entries will be kept, and whatever new entries are coming, they will be kept. And after that when the part of this will be done, okay, so the objects values will also be kept, object values will be kept, the committed values will be kept, and then when this is completed, this file will not be used any longer. Then what will happen, new this reorganized file will be, recovery file will be used. Okay, so this is something about your logging. Now we can see something about shadow versions. This is another option for this thing, recovery files. So these shadow versions, actually what will happen, it uses a map to locate versions of the servers objects in a file called version store. Okay, actually what it's saying is, you will have a version store, you will keep the server objects there, and you will have a map where you will keep the information of the addresses where the new values of these things are there. Okay, so you will have the object and the pointer, object and the pointer, kind of this thing. Okay, so this map will keep changing as the values of the object will be updated, right? So example is there in the next slide, don't worry. So the map associates the identifiers of the server's objects with the position pointers, positions of their current version in the version store. Okay, you will see there will be a version store where you will store the values. Okay, this will be P1, P2, some values. So this will be for object, whatever object value, whatever object, this will be kept in this map file. Okay, you will understand with the example on the next slide. So the versions written by each transaction are shadows of the previous committed versions. So see, in this example, suppose this is a map at a start where it says this is a checkpoint where till this the values are consistent, no problem. So it says 100, 200 and 300. Here we are saying that the value of A is at P0. You can see P0 dash and P0 double dash. It is P0 dash and P0 double dash. Definitely values are there stored in a memory, they will have different address, but still for understanding that these all are consistent value on the same stage, so we are saying P0. Okay, map with T commits. When T is committing, what happens? It has kept certain values. Now it has updated certain values of A and B. So the current committed version of A will become P1 and for B it will become P2, right? Now these values, assume there is another transaction U which is updating the values of certain objects, maybe C or D, I don't know. So if these are the committed values, maybe they are also updating B and C, right? But whatever values these are, there will be a next step when this will commit. In that case, A will point to a certain place, maybe to P1 only, and B will start pointing to I think I don't know, P3 or P4, and C will start pointing to P4. In this way, map will be after U will commit, right? And this version store will keep working, new versions of new values will keep coming. Okay, in this way this shadow versions will work. At the same time, you can see we have just entry of these values and the objects, but we don't have the values, I should say the information about the transactions status, right? So along with this map, you will also have a separate file, you will call it transaction status file. Okay, transaction status file. In this file you will store the information of the transactions. The transaction T, you will have new entry whenever something happens to a transaction, it is prepared, okay, with this list. Okay, then there will be another entry for T when it will commit, right? there will be another entry for you then when it is prepared with the entries. When you will commit, there will be another entry. So this will be a transaction status file. So these are the things, and this will be kept in your storage. So these are something about this thing, and shadowing, logging and shadowing, and these are the ways where recovery files are kept and used to recover in case of crashing. So these were something that we saw about transaction recovery, and basically we have been kept seeing these things about failure and recovery. We have seen this fault tolerance in during commit, that what happens if certain things happen during commit. We have seen there is something called two-phase atomic commit protocol, right? So now here we are saying that actually when the system crashes, how these things are recovered. At the time of two-phase commit, we have seen that when it says that I am prepared, then actually it saves something in permanent storage, and it can be it says that now whatever even the system crashes, I can commit, right? So this is the way how it keeps in mind that we can recover. So for recovering these recovery files, maybe logging or shadowing, these kind of techniques can be used. So that is all related to this. Thank you.